All right, this is a kind of a goofy problem, but it's very doable. We're looking at 0 to pi over 3, and it looks super complicated, but just stick with me. Looking at sine of theta plus sine theta tangent squared of theta all over secant squared of theta d theta. Now, if you know your, I guess we need to factor first. So I just rewrite that this is equal to factoring out a sine of theta in the numerator. So let's do that trick first. That's just factoring skills. You should know that from Algebra 1. It's the greatest common factor. If you don't believe me, distribute it in. You'll see it's the same thing. But in pre-calc or even Algebra 2, we learned that 1 plus tangent squared is always equal to secant squared. So that's a trig identity. If you're confused, I would tell you to Google it or go back to pre-calc. That 1 plus tangent squared is equal to secant squared. So we can cancel those two things out. So now we're ready to just look at this and say, okay, well, do we know the antiderivative of sine? And we do. It's negative cosine. If you don't believe me, just, what's the derivative of cosine? It's negative sine. So if it's negative cosine, it would be positive sine. And that goes from 0 to pi over 3. Well, now we can start plugging in your upper and lower bounds. Maybe I'll switch colors again, because pi over 3 is up here at this ordered pair. And then 0 is this ordered pair, 1, 0. So as we plug in pi over 3, we're looking at that value. So we're looking at negative 1/2 minus, we're going to plug in 0 and cosine's the x-coordinate, so it becomes minus negative 1 because the negative is still there. So really what we're looking at is negative 1/2 plus 1, which gives me positive 1/2 is your correct answer. So hopefully you were with me on every step of the way, but this is the correct answer.